Magandang araw! Sama-sama tayong matuto sa Teacher Sal Learning Resource Channel.
Revised K-12 Curriculum, Science 5, Quarter 1, Week 8. Our topic is all about using balances and thermometers, planning simple scientific investigations, using appropriate simple science equipment. Can anybody from the class recall for me what were the different units of measurement that we learned about? The units of measurement that we learned are the milligrams, grams, kilograms, and degrees Celsius, a type of a centigrade scale. What physical quantity do grams, milligrams, and kilograms describe? All of them describe mass. As you may recall, the mass of an object is the amount of matter it has. On the other hand, what physical quantity does the degrees Celsius describe? It describes temperature, as you may know. The temperature of an object tells us how cold or how hot an object is. Which among the three measurements describes the greatest amount of mass? 1 milligram, 1 gram, or 1 kilogram? 1 kilogram has the greatest amount of mass, as 1 kilogram is equal to 1,000 grams. On the other hand, the milligram has the least. Now that you are all set, we can now learn about the different simple science equipment that we use in the laboratory for measurement. Class, have you ever joined your parents on a trip to the market before? Whenever your parents buy fish, meats, vegetables, and rice, what do the vendors do these items before mentioning their price? The vendors weigh the items on a scale first. These weighing scales allow vendors to know how much of the item is being bought in mass and for how much it can be sold for in cash. Now, I also want you to recall the times when you have had a fever. What did your parents use at home to check your temperature? How about what a nurse or doctor used to check your temperature? Using the back of our hand if someone is warm or cold. But it is not enough to tell us whether someone is sick or not. They use thermometers to accurately measure temperature. On the screen, your teacher will be flashing 4 pictures for each word, and you must guess the correct word based on the clues given. In the same way, you will all learn how to operate different kinds of equipment to find out how much mass something has and how hot or cold it is. For the first set of pictures, you're right, the correct answer is thermo. Next. Very good, it is balance. Next. You're right, it is digital. For the next picture, very good, it is electronic. Lesson 1, using balances and thermometers. The units of measurement that you learned in previous lessons are used to describe the physical characteristics of an object. Milligrams, grams, and kilograms are used to describe how much mass an object has, while degrees Celsius is used to describe how hot or how cold something is. In this sense, what can we use to measure the mass of an object? Balances are instruments that are used to measure mass. Balances can either be mechanical or electronic. A mechanical balance only uses springs, levers, and reference weights, and does not need electricity at all to operate. An object is placed on the platform of a mechanical balance, and the said reference weights are then moved around until both the object being weighed and the reference weight are balanced, which will give us the mass of the object. An example of a mechanical balance that works this way is a triple beam balance. This is a triple beam balance. Note the slidable weights on the beams. On the other hand, an electronic balance, as the name suggests, uses electronics in the form of a simple computer. A person can place an object on the pan of an electronic balance and determine the mass just by looking at the LCD screen of the balance. The computer does all the balancing and measuring for you. Examples of electronic balances are top-loading balances and analytical balances. An analytical balance can measure much smaller masses than a top-loading balance. A top-loading balance left and an analytical balance right. Note how many more zeros the analytical balances has. These balances, being high-precision instruments used to measure very light substances in the laboratory, expresses mass in grams and milligrams. To measure objects with greater mass in kilograms, bigger scales are used. Bathroom scales are the scales that people use to measure their own mass. Physician scales are used in clinics, while floor scales can be used to measure the mass of packages. From left to right, a bathroom scale, a physician scale, and a floor scale. In this sense, what can we use to measure the temperature of an object? Thermometers are instruments used to measure the temperature of an object. There are two types of thermometers, commonly used in the laboratory: liquid in glass thermometers and digital thermometers. Liquid in glass thermometers, as the name suggests, are thermometers that have liquids encased in a glass tube. Two of the liquids that are commonly used in these thermometers are mercury and ethanol, with ethanol being regarded as the safer alternative. When exposed in a warm area, the liquid inside the glass tube expands. In a cool area, the liquid shrinks. The rising of the liquid in the tube corresponds to an increase in temperature, while the lowering of that same liquid corresponds to a decrease in temperature. A laboratory-grade liquid in glass thermometer. The liquid in the glass tube is dyed blue for visibility. Digital thermometers, like electronic balances, make use of electronics in the form of simple computers. It calculates the temperature of an object and shows the results on its LCD screen. Due to this, digital thermometers are also faster at reading temperature than liquid in glass thermometers. A laboratory-grade digital thermometer, the power button is first pressed to turn it on. Then its probe is immersed in the substance to measure its temperature. For activity number 1, identifying scales and thermometers. It is good for 15 minutes. Identify the science equipment shown in each item. Write your answers on the space provided below the images. For day 2. For this part of the lesson, you will now be practicing how to use different scales and thermometers. Let us start with the balances to help us measure the mass of a given object. To use the triple beam balance, do the following. Move the slider's reference weights on each of the beams to the leftmost side so that the balance reads 0. The indicator on the far right must also read 0. If the indicator does not read 0, adjust it by turning the screw under the balance span. Place the object to be measured on the pan. You will see that the indicator will go above the 0 mark. To start measuring the mass, first move the biggest slider, the 100-gram slider, until the indicator is aligned just slightly above, if not exactly on, the 0 mark on the far right. The arrow marks on the sliders that points to the number it lands on indicates the mass of the object. If the slider causes the indicator to be aligned exactly on the 0 mark, you may skip steps D and E. Next, move the second largest slider, the 10-gram slider, until the indicator is also just below, if not exactly on the 0 mark on the far right. Move the smallest slider until the indicator falls exactly at the 0 mark. Add the masses recorded on each of the beams. This will give you the overall mass of the object. This time, let us try measuring the mass of an object using an analytical balance. The steps in using an analytical balance are as follows. Clean the surface of the balance. Make sure that your balance is on a flat surface and leveled. To check the leveling, look at the leveling bubble and make sure that the bubble is at the center of the circle. If the bubble is not centered, adjust by turning the leveling screws on the bottom at the back of the balance. Close the chamber doors and press the power button. A row of zeros will appear on the LCD screen, indicating that it is now ready for use. Place the weighing container on the balance pan. Close the chamber doors after you do so. As the weighing container has a mass of its own, you need to tare it. Tearing is the process of taking the mass of the weighing container into account so that the mass of the substance you want to measure is what you directly get. To tare, just press the Tare button on the control panel of the balance. Slowly add the sample that you want to measure, the mass of onto the weighing container. You may remove the weighing container from the balance first to make it easier to pour the sample, provided that no one touches the controls of the balance to avoid removing the tare. With the sample and container on the pan, close the chamber doors and look at the LCD screen to get the mass of sample. Alright, all of you are now familiar with how to use the two balances. This time, let us learn how to use the two types of thermometers, the liquid in glass thermometers and digital thermometers. To use a liquid in glass thermometer, do the following. Calibrate the liquid in glass thermometer by flicking or tapping the thermometer with your finger. This is to ensure all of the liquid will fall to the bottom of the thermometer. Do not flick the thermometer too hard. Do not shake the thermometer. Doing these two actions will damage the thermometer. Place the thermometer in the sample. Make sure that the bulb of the thermometer is immersed in the sample. Do not let the bulb touch the base or the wall of the container. Keep it suspended by holding the thermometer up. Watch the liquid rise. If the sample is hot, or shrink if the sample is cold. Once the liquid stops moving and stabilizes, record the measurement. Depending on the graduation of your thermometer, You may have to rate it in 2, 0.00, or 3, 0.000 decimal places. Remove the thermometer from the sample and wash it with deionized water or distilled water before using it again or putting away. This time, I will teach you how to use a digital thermometer. The steps in using one are as follows. Hold the digital thermometer on its plastic parts. Do not touch the metal part of the thermometer while you do a measurement. Press the power button on a digital thermometer. The LCD screen will flash to indicate that it has been turned on. If there is a switch or button that allows you to change the temperature scale from degrees Celsius to Fahrenheit, make sure to set the scale to Celsius. Submerge the metal part into the sample that you want to measure. Just as with a liquid in glass thermometer, do not let the metal part touch the base and sides of the container. Keep the thermometer suspended by holding it up. Wait for the numbers on the LCD screen to stop switching. The numbers you end up with is the temperature of the sample. Wash the metal part with deionized or distilled water and dry it before using it again or putting it away. For your lesson activity, measure and compare. The class will be divided into 4 groups. Each group will be given a simple science equipment to use to measure the mass and temperature of 5 things. Groups 1 and 2 will be given a triple beam balance and an analytical balance respectively and are assigned to measure the mass of 5 samples. For the sample, we have a stick of chalk, a piece of candy, a spoonful of brown sugar, a bag of tea, a stick of instant coffee. Groups 3 and 4 will be given a liquid in glass thermometer and a digital thermometer respectively and are assigned to measure the temperature of 5 samples. For the samples, a glass of water, a fresh milk, cola, orange juice, and iced tea. Write the temperature in centigrade. Afterwards, the groups will then present their answers to the class. Groups 1 and 2 will compare their measurements, while groups 3 and 4 will compare theirs. The group's output and presentation will be graded. For Day 3, Lesson 2, Planning Simple Scientific Investigations Using Appropriate Simple Science Equipment. Now that you know how to use simple science equipment, it is time for you to learn how to determine which equipment is best used for measuring something, whether it be mass or temperature. What instrument, equipment is used to measure mass? When it comes to measuring mass, a balance must be used. Do recall that there are many types of balances, and we must take into consideration the objects we want to get the mass of. The most well-known laboratory balances are triple beam balances and analytical balances, which are used to measure samples with small masses. If we want to get the mass of a person, we cannot use a triple beam balance, nor an analytical balance, as both tools are too small for such a purpose. In this case, a bathroom scale would be more appropriate. This is a person using a mechanical bathroom scale. For measuring the mass of large and heavy objects, such as packages, sacks of rice, and the like, a floor scale is used. Floor scales are built in such a way that the said objects can be loaded on its platform with minimal lifting. Floor scale measuring the mass of a 50-pound block. 50 pound is equal to 22.7 kilogram. What instrument or equipment is used to measure temperature? When it comes to measuring temperature, thermometers are the tool of choice. Just like with choosing the right balance, depending on our intended purpose, the same can be said for thermometers. If we want to measure the temperature of a person to determine whether they are sick or not, we cannot use laboratory-grade liquid in glass and digital thermometers, as they are too large for bodily use. Laboratory liquid in glass thermometers also do not have kinks, which are structures inside the glass that would prevent the liquid from falling back down so that the temperature reading will stay for a while. A clinical thermometer with a kink, the kink encircled in red, prevents the liquid from falling back down. Instead, clinical thermometers are used which are much smaller in scale and are appropriate for use with humans and animals. These medical thermometers may be in the form of liquid in glass or digital thermometers. The clinical liquid in glass thermometers have kinks in the structure that would allow us to look at a temperature reading for longer. In the same way, the clinical thermometers cannot be used to measure the temperature of very hot objects, such as that of boiling water. Both clinical liquid in glass and digital thermometers only give readings within a range of 35 degrees Celsius to 42 degrees Celsius. Clinical thermometers are intended for measuring the temperature of the human body, which falls within this range. For activity number 2, what science equipment should I use? Determine which science equipment or measuring tool is best used for a particular sample situation, or test by matching column A with column B using lines. Here are the correct answers. Using the skills that you just learned through this lesson, we will now try to prove that gases and liquids are matter. Matter is anything that occupies space and has mass. For as long as something has mass, it is occupying space as well, since mass describes the amount of matter in a substance. Through this, we can prove that if a substance has mass, it is therefore occupying space and is also therefore matter. The three basic states of matter, solid, liquids, and gases, are regarded as such since they all have mass. We know for sure that solids and liquids have mass since we hold and see them daily. But what about gases? Can we really say that they have mass if they feel weightless? For us to get the mass of the liquid and the gas itself, we must tare our balance with the mass of the container. With this, it is best to tare the container we are going to use first before we pour our liquid or pump our gas into the container. Once you have measured and recorded that a gas does indeed have mass, we can now confirm that gases are matter. One way to determine this is to measure the mass of gases within a container using an analytical balance to reliably contain gas inside a container. What kind of container should we use? A balloon would be a good container to contain gas, as a balloon would inflate as we pour more gas into it. We measure the mass of liquids the same way, by first containing the liquid in a container before placing it on an analytical balance. For day 4, lesson activity experiment. Do gases and liquids have mass? Do gases and liquids have mass? Here are the materials needed. Analytical balance, 100 ml beaker, small 4-inch latex balloon, balloon pump, 100 ml water. Part A, measuring mass of the liquid. First, make sure that the surface of the analytical balance span is clear of dust and debris. You may now Wipe the pan with a clean cloth. Make sure that the analytical balance is leveled as well. Once all this is done, plug in the analytical balance and turn it on. Start with measuring how much mass 100 ml of water would contain. Do so by placing an empty 100 ml beaker on the pan of the analytical balance and closing the chamber door. Once the mass of the beaker flashes on the LCD screen, record it first and then press the tear button to tear it. Remove the beaker from the analytical balance and pour 100 ml of water into the beaker. Make sure there are no droplets or moisture outside the beaker. If there are, wipe it with a clean, dry cloth. Carefully place the filled beaker on the analytical balance pan and close the chamber door. Record the measurement flash on the LCD screen. Carefully remove the beaker from the pan. Do not pour out the water. Watch the LCD screen show a row of zeros and wait for 10 seconds before putting the beaker back on the pan. Do this twice, recording the measurement each time. Complete the table with your recorded measurements. Part B. Measuring mass of a gas. Measure the mass of a balloon of gas this time. Wipe the surface of the analytical balance pan with a clean, dry cloth. Place the unfilled small latex balloon on the pan and close the chamber door. Once a measurement has been given, record it and then press the tear button to tear it. Using the balloon pump, fill air into the balloon until it is tight full. Place the balloon onto the pan and close the chamber door. Record the measurement flash on the LCD screen. Remove the balloon from the pan. Do not pop it or release the air. Watch the LCD screen show a row of zeros and wait for 10 seconds before putting the balloon back on the pan. Do this twice as well, recording the measurement each time. Complete the table below with your recorded measurements. Does water having mass prove that it is matter? Why or why not? Did you expect for the balloon to have more mass once it had air filled onto it? Why or why not? Based on your measurements, does air have mass? If yes, how much mass did the air in the balloon have? How did you compute for your answer? If air has mass, does it prove that gases are matter? Why or why not? Exit ticket. As a review activity, please prepare an exit ticket, summarizing one concept you've learned from our class discussion and experiment. One exit ticket is equivalent to a merit point in class. Choose one question to answer. What type of equipment do we use to measure mass? What type of equipment do we use to measure temperature? Would you use an analytical balance to measure your body weight? Why or why not? What kind of balance should you use? Would you use a laboratory liquid in glass, thermometer, to measure your body temperature? Why or why not? What kind of thermometer should you use? Reflect on the following questions as we relate measuring temperature with global warming. What is global warming and climate change? How can climate change affect us negatively? The comfortable room temperature range for humans is 20 to 25 degrees Celsius. How would you feel if the temperature was below 20 degrees Celsius? How about if it is above 25 degrees Celsius? How can we reduce global warming? For your formative assessment, multiple choice. Read each item and its options carefully and circle the letter of the best answer. Which balance has three movable weights that you can slide around to determine the mass of a sample? You're right, it is C, triple beam balance. Which equipment is used to measure the mass of large and heavy objects, such as packages and sacks of rice? Fish scale, floor scale, physician scale, or bathroom scale? Very good, it is letter B, floor scale. Number 3, which tool would you use to measure the body temperature of a person? Food thermometer, digital thermometer, clinical thermometer, or laboratory thermometer? It is C, clinical thermometer. In liquid in glass thermometer, what happens to the liquid inside as its bulb is placed on a cold sample? The liquid freezes, the liquid shrinks, the liquid expands, the liquid blows up. You're right, it is letter B, the liquid shrinks. Suppose you are tasked to measure the mass of 5 rice grains. Which scale or balance would you use to get its mass? Floor scale, bathroom scale, analytical balance, top loading balance? It is letter C, analytical balance. Why are clinical thermometers not suited for measuring the temperature of boiling water? You're right, the correct answer is letter B. Which between the two types of thermometers are faster at measuring temperature? Very good, it's letter A, digital thermometers. What structure in clinical thermometers prevents the liquid inside it from falling below a certain point? It is letter B, kink. A physician scale is used to measure the mass of a person or animal. What unit of measurement would a physician scale have? It is letter B, kilograms. When using a liquid in glass thermometer, why is there a need to tap it lightly first? You're right, it's letter C. Illustration, draw what is as in each item. An analytical balance, a liquid in glass thermometer. Here are the correct answers.